Hey everyone, and welcome to Bitovi's Learn Docker training. First, remember, if you're going to follow along, you will need to have Docker Desktop installed on your machine. Don't worry, it takes less than 5 minutes to install, and the link to those installation instructions is in the description below this video. Second, just so you know, Bitovi has a full roster of Academy courses you can browse and take at your own pace. Everything from advanced JavaScript to this Learn Docker training is available on bitovi.com/academy. So you can check that out using the link in the description below. The Learn Docker training has 7 sections, which we'll cover in this video. But in this video, you'll also get exclusive access to an 8th section to help you level up your containerization skills. So stick around. Now, before we dive in, I want to give you a quick overview of containers and Docker, so we all have the same baseline of knowledge before we dive into the training. First, imagine you have a box called a container. This container can hold all of the things your software needs to run: the code, libraries, settings, and even the operating system components. Docker creates and manages these containers for you. So let's break it down even further. First, what is Docker? Docker is a tool that helps developers package up their software and all the necessary things it needs to run into a single package called a container. This container can then be easily moved from different computers or environments, ensuring your software behaves the same everywhere. So what's a container? Think of a container as a self-contained environment for your software. It includes everything the software needs, like code, libraries, and even the operating system. It's like a portable and consistent home for your web application. Docker takes care of the complexity of setting up this environment. It makes sure that your software runs the same way on your laptop, on your colleague's computer, on the server in the cloud, or anywhere else. Imagine you're working on a team project. Everyone might have slightly different laptops, and the server where the software will eventually run might be different too. Without Docker, setting up the same environment everywhere can be tricky and time-consuming. But with Docker, you create a container that works the same way on everyone's computer. This reduces that "it works on my machine" problem that we've all encountered. Docker simplifies testing and deployment. Since you know your container works on your laptop, you can be more confident that it will work the same way when it's running on a server. You can also easily share your container with others, ensuring they have the exact same setup to work with. So to dive into a real-world example, imagine you're building a web application. With Docker, you can package the app code, the web server, and all the required libraries into a single container. This container can then be moved to a colleague's laptop for testing, to a staging server for quality checks, and finally to a production server for the world to use. And because it's in a container, you're less likely to run into compatibility issues. In a nutshell, Docker helps create a consistent, portable, and isolated environment for your software, making development, testing, and deployment smoother and more reliable. Remember, just like learning anything new, getting comfortable with Docker might take a bit of practice, but it's a great tool that can make your life as a developer a little bit easier. So let's dive in. Welcome to the Learn Docker training.
This is exactly the Docker concept. So traditionally, if you develop an application, you will package the source code, binaries, everything into one, and then you will deploy it into the only operating system or environment that is compatible to your development that you did, right? That was traditionally. So now if you want to deploy the same application onto another environment, let's say you develop it for Windows and you want to deploy it on Ubuntu, it's going to give you errors, bugs, and stuff. However, with Docker, you bundle the dependency and source code into image, and then you can just push into the Artifactory, just like apartment. It's gonna, I will show you in the next slide a little bit more clearly, but it's gonna use the pieces of the operating system, but on its own, it's gonna be very lightweight and fast, because it's not using everything of its own. Okay, so here, this is going to give you maybe a little bit more clear picture what I was talking. So for example, we have virtual machines. First, why do we need virtual machines? For example, you have a Windows laptop, but you want your application to work on Ubuntu. So it's not that you go to the market and buy another computer, right? In virtual machine, you have your small computer in one very big computer, you can say, and this small computer will have its own environment, own operating system. For example, this virtual machine is one small computer. This is another small computer which is installed on this very big, powerful computer. And here, each virtual machine is getting the exact copy of operating system. So making virtual machine very heavyweight, very slow. However, in the Docker architecture, we have this Docker engine and we have these small containers deployed on that. So these containers will just take a piece from the operating system. It will not copy the whole complete operating system inside it. This will make it very lightweight and very fast and efficient. So now you can multiple different type of environments, and your application can be deployed into different environments, different operating system with very lightweight process and with fast speed. These are the three components that we will cover in our practical session as well. But just to give you the overview, first is the Dockerfile. This is going to be just simple text file, a template, read-only file, where you write multiple lines. These lines are referred to as instructions, and it tells what our container will do. We will explore the whole structure of it in a few minutes. And then from this Docker file, we create a static artifact that is referred to that is referred to as image. And this image we can share, we can push it into public or private artifactory, and then anybody can make use of this image to deploy container. Okay.
I wanted to call out here a common misconception. The terms image and container tend to be used interchangeably, and they're not technically the same thing. So the image, like Karam was saying, is the static, we sometimes say idempotent, or not idempotent, but unchangeable image, in the sense that to create any changes, you have to create a new artifact. And that's essentially a static entity. You can then run that image as a container, and you can create as many containers off of that same image as possible, or as needed. And the container will always be has a life cycle. It can either run one command and be done, or it can run kind of a never-ending command and live for as long as it needs to. That's how you manage various types of applications or services. Instance of that image's definition. The container is, we just talked about what is Docker with Chrome, so we're going to go into actually building a Node app, and I'm going to do this from scratch. And so this is a very simple example, but the concepts all apply to even the most complex examples. So for this app, it's a very simple Hello World website that's written in JavaScript, or rather in Node. And all you need is your package JSON, which defines your dependencies and your start scripts, as well as the name of the app, of course, and our actual index file, which reports the state or reports the message to a request to it. Very straightforward. And you can see that one thing to note here is we're talking about an environment variable for our port, or 3000. So if we have an environment variable named port, it will use that port to expose itself to the outside world, or it'll just pick 3000 if nothing is set. This is about as simple of a website as you can get, and it's just used as an example. So I'm going to take these pieces of code and create my package.json. Okay. And I'm going to create actually I need to create this in source. I'm going to create index.js. Okay. We have that. All right. And then so all we need to do to run it is install and start. So we can do and install. So this will pull all of the dependencies. And one thing I'll note, kind of as a side note here, If we were doing this in Git, if we were doing this in source control for our company, and you were sharing it with other people, you would be putting this in Git or GitHub or similar, GitLab, Bitbucket, they're all the same, and you'd be pushing that to the to your shared repo. If you were to do that, you'd want to put this node modules into a git ignore. And so this node modules does not need to be pushed outside of this environment, but that's a side note and we can get to that later. And then we'll do an npm run start. Okay, and it starts up, thankfully, and we are listening at localhost 3000. And you can either go to a browser to do that, or you can just do Perl localhost, and you get hello world. Okay. If we were to go to the browser, we just go localhost. Since I'm in full screen, I can't see this. So we'll just leave it at that. But if we were to go to a web browser, it would just say hello world.
Perfect. So now we want to containerize what Max just showed you, this application. And to start with, we will write a Dockerfile. That's what I'm going to show you. We all would going to write together. So you create a Dockerfile named Dockerfile in your environment, and let's write. So each line, as I told you, each line of Dockerfile is referred to as instructions. So we are going to write few instructions that's going to containerize our application. So the very first instruction of any Dockerfile is always from. So from specify that which base image you want to use for this application. For example, in our case, we are using the node colon 15. So node is the base image that's gonna get pulled from Docker Hub. And then 15 is the tag, which specify the version of the image. So in our node image, we have the Node.js installed already on Docker Hub. So similarly for your application, there are many images already present on Docker Hub, which can have the dependencies or library that you need for your Docker application, So in our case, it's Node. So from specify that what is the very base image that you want to use. And on that image, the further instructions would be executed that we're going to write now. And the next instruction for our environment is argument. So here we have two instructions to define the variables. One is arg, and the syntax is you write arg and then the name of the variable, and then you give the value. For example, we are going to use 8,000 here. I guess Max used 3,000, but let's use the 8,000 here. And then we have another, I'm going to tell you the definition of both. So another variable that we define using env, and the syntax is again same. You write the name of your variable and then you provide the value. You can provide the value again in variable as well. So here, the only difference between environment and argument is this, that environment, you can use it during when the container is already running, as well as when you are building your Docker image. So in a few minutes ago that I showed you that you from a Docker file, you create image, and from image, you create a container, right? So environment you can use during the image building process as well, and when the container is already running. However, if you want to override this, whatever is arg variable, you can do it only when the image is getting built, not when container is already running. So this is the basic difference in defining these two types of variable. There are multiple images on Docker Hub, and we can always Google that which image have the basic libraries and binaries.
Or if you're building your own application like we're doing here, you would pull a base image that has ideally the bare minimum of components that you need to run your application for hopefully self-explanatory reasons, but just to keep the image size low, maintenance of it low, small images start up faster, so on. One other thing I wanted to point out about the arg versus env. So if something's set as env, it's going to be copied into the environment of the context of that running container, so that your application can read that environment variable during runtime. It cannot read an argument variable that's set in the Dockerfile. I believe either one of those can be set also at the command line at build time. So even if you have arg port 8000, when you build the container, you can override that with a parameter on your command line, which, like almost any other framework, the command line parameter will take precedence over something set higher up in the hierarchy. And they do this, they set this up for security reasons. You may need to set a secret, like a password, for example, when you build the image that you do not want being exposed in the running container for a user, for someone who may not be part of your organization, may not just be a public user. So you'd use arg for that, so you can control it locally during the build, but it doesn't get exposed in the environment to the application. If you don't care, or if you do want that to be accessible by the application, then you want to use environment. And in this case, we're using both just to kind of illustrate that point.
And as like Max already explained, like this node image, when it was created, it was also created from a file like this. There also they made use of another base image that had
right.
Yeah. So I guess in this case it was Debian. So it goes in layering like this, that each image you create, it has a Dockerfile where there is usually a base image. And it goes until, I guess, there is a scratch image on Docker Hub. So for example, even now we are using this base image, but what we are going to do in next few minutes, we are going to create our own image from this. Let's move forward to our next instruction, which is the work directory. So it just set the working directory for our next instructions. So in our case, we are setting it to app. So what will happen when container will start under root app, all the next instruction would be executed. Okay, so just like a present working directory. And then the next instruction is copy, which copies whatever you want to copy from your local environment inside the container. So in my case, I already have this source directory that Max showed you in last when he was building a Node application. And under source directory, I already have index.js, and I want to copy this inside container under the path root app root source. So I'm copying it. So first is the source, that is source. I have it on the same level where my Docker file is. So I'm just writing source, and I want to copy it on the same, like on the same path. So it will go inside, it will, and once we start a container, if we go inside container, you'll be able to find it under app, and it will be like this. Okay, so our content from our local directory is gonna be copied inside the container. This is what copy instruction is for, and we are copying our package.json into the app, means into the present working directory. So to specify that, we are just writing dot. If you have a specific path where you want to copy, you specify that. If you want to put it into the current working directory, just put dot. And that's about the copy instruction. And next we have 3 more instructions. We have run instruction. Here we write any command that we want to run when we are building an image, okay? So when we are building an image, we want to install the npm inside the image. So I wrote that command here. And then next instruction is expose, which expose the port on which our Docker will be listening. And this we are providing as an environment variable. And next instruction is cmd command. And here also we write, okay, so we might get confused in these two, but run whatever command you want to run when you are building an image, you write it in the run instruction. But when the image is built and now you want to start a container from that image, then whatever command you want to run, you write it under the CMD instruction. But this is the very basic Dockerfile for our application that Max just showed you, and we are going to containerize it now.
All right, so we just talked about writing a Dockerfile. Now we're going to actually run the Dockerfile. So I'm going to create a new file, Dockerfile. Dockerfile with a capital D is the default name. If you do not specify a file, it will look for that file. But you can use it any name really, but then you have to specify it as a command line argument. So just keep that in mind. So this is the same thing we did. So the build is Docker build, and then we use this -t for its tag, but we're actually just giving it a name. We're not applying an actual tag, but we're naming the image my Node app. And then this dot at the end is easy to miss, but it tells the build engine where to look for all of its files. It's called the context. Typically, we build in the directory that the Dockerfile is located in, so we almost always use dot. It is possible to do other things. It's important to keep in mind that the build engine can only access files that are in its context. So in this case, if we're using dot, so our local or the directory we're running the command in, it can only access files at that level and below in the hierarchy. It cannot go out to some other folder elsewhere and pull something in. I can't speak to the logic behind that, but that's the way it works. We'll just go and run this. So it's going to do a bunch of stuff here. So you see it's pulling that node image right here. So from Docker.io, node 15, a specific hash. So we know exactly what image it's pulling. And you can see here it's actually running each of those commands in this Docker file. I've done this many times in the preparation for this webinar. So a lot of them are cached kind of behind the scenes in Docker, but you can see how it's evaluating each line and running each one. So if I had taken the extra step of actually going and removing all of the back-end layers of cache that Docker keeps, which is not hard to do, I just didn't do it, it would have actually rerun all these commands. But that's, again, one of the huge benefits of Docker is, and I won't get too deep into this, but every one of these lines creates a layer, as it's called, in the final image of a Docker image. And as it goes through each build, it actually evaluates the checksum of each of those layers. And if it hasn't changed, it will skip it because it knows it already has what it needs. And you can use that to your advantage as things get more and more complex. If you've already built a big part of an image and you're just changing a small part, it'll just pull the cache of the big part and change the small part. That's why you want to, in general, put the things that are more likely to change in the future down lower in the Docker file, because as soon as one layer changes, it has to rebuild all the following layers. Let's see, what else? So we built and it named it to, so this just means that we built it locally. If I do a Docker image ls, it shows me, well, these are all my other, you can ignore anything else, but here's the one we just built. My Node app, in fact, if I go over to my shell, you'll see it later. Docker image ls, there. So my Node app, we didn't specify a tag after a colon, so it just puts latest on it. This is the unique hash of the image that we can always validate if we push this and re-download it somewhere else, whether or not we're getting the same exact image, size and time. Oh yeah. Okay, so on the documentation, we see all the same stuff. This is some of the stuff that would have run if it wasn't cached, right? And you can see actually right here what I mentioned, every new step creates a layer stored locally as a cache for later use. And here, when we do run npm install, it's doing exactly the same thing that would have happened if we ran it on the command line locally. So, again, you can think of run as just anything you would do to set up your application to run locally, you want to do in the Dockerfile so it gets captured and is done every time. That's one of the beauties of most of these DevOps tools is it allows you to create something that you don't have to do manually every time. Okay, we built it. Now let's run it. Let's run it. So let's go through the command Docker run, give it a name, my container. So this is the actual instance of the container, not the image, but the instance of the running container will have a name. If you don't give it a name, we can try it. We'll run it without a container. It gets a randomized name that is a combination of an adjective, a list. They have some huge list of adjectives, and then there's a huge list of like meaningful scientists throughout history that they randomly select from. And so every image will get adjective _ name, almost guaranteed to be unique image name if you don't specify one. It will, of course, also get a hash as an ID, which is useful for scripting. So yes, we are exposing a port -P 8000 8000. And yeah, well, we already said that in the Dockerfile, right? We're already exposing port 8000. We have to do it in both places. It just means that when you launch the container from the Dockerfile, the container will know to expose that port. It'll be listed. It'll open up that port on its, I can't think of the right term, but in the context of its instance, it'll be listening on port 8000. But we still have to tell our host system that we want to talk to that container on this port. So we're essentially opening up our local firewall. We're creating a connection locally into the containers connection. And you can play lots of tricks with this. You can only have one instance or one thread attached to any given port. That's not a Docker specific. There's any operating system can only have one thing listening on one port. So what if we want to have two containers running? And we'll actually look at that later. -D just means detached, which means we get our shell back when we run it. Otherwise, if we don't do that, the thread of the container running will take over our shell until we exit. And then the last thing always has to be the image that we want to run. So here's where we specify the image name, and we're specifying latest here. So this is an example where we built just -t my node app. We didn't give it a tag. We just gave it a name. And here we're giving name : tag. I think we could get away with not even specifying latest. Yeah. And as it says here, if it does not exist locally, it'll automatically go and try and find it on Docker Hub, which is a really nice feature of Docker. You can run almost anything just from the command line. But we know we have this in our local container, our local registry, so we will run it. Okay. And it's not my container, it's my node app. Well, you should change that. Oh no, I'm sorry, too late. That's the name of the container. So we're running it. All right, we get our hash back, which means it's up. All right, what do we do now? How do we know it's up? For me, almost muscle memory is our container up. So Docker PS. Just like on Linux, you might use PS to look at running threads. We'll do Docker PS, and there is our running container. So looking back at the command line to launch it, my node app latest, we're running the image my node app latest. We got this hash back when we launched it, and here's the container ID 9B63B. Okay, so that's our hash. So we can use that to reference this container later on. Here's the ports that we expose. So localhost is pointing at or access that port 8000 will redirect into port 8000 on referencing. And here's the name we gave it. Assuming nothing's crashed, we can keep doing that and we'll get the same result. Let's see. Okay. We can look at the logs. of this running container. And that's what's there. Same thing we did see when we ran it locally, right? We can also, as I mentioned, use that container ID. Same thing. Excuse me. If something is running actively and you want to kind of see what's going on, if it's behaving correctly, you can watch that. Docker logs. Well, I don't have watch apparently, but in other places we can do that. So there's other ways that you can just. Oh, I'm sorry, it's Docker. It's minus F or follow. Now, if something else were to happen on this container and it logged, which is the application's responsibility, not Docker's responsibility. But if the application logs something, you'd see it here. Since we're following it, it's like a tail. It's like tailing a log file. And we can use it. Okay. All right, Docker stop. And then Docker RM. So the docs here say Docker RM minus F. That is going to stop the container and force remove it. So let's talk about that real quick. So we have this container and we started it just with run. We didn't tell it what to do with the container when it stops. If we Docker stop that container, this is a big container. So it's taking a minute to whatever Docker's doing in the background, offloading the cache, offloading some stuff. Okay, but it's just stopped. It's not running, but it's stopped. If we do, and I'm using some aliases here, which we'll talk about, but if the full line would be Docker PS minus A for all. We have some other images that are stopped, but not removed. This is just some other stuff I use. This is actually Minikube, which we'll talk about later, a database. And here's my Node app. It's stopped, okay? Exited 18 seconds ago. We can start it back up. This is why I use aliases, because my fingers don't work. Docker start that container, okay? It's back up. And if we were to curl local host, we get our hello world back. If we stop it, I could be using the container name in all this. I just happen to have the ID in my clipboard. And if we curl, we get nothing back. That's a good way of proving that the container is up or down as I respond to a curl. Let me start it up again. Now, if I do what he's got in the docs, RM minus F. Actually, I'm going to start with not doing the F. So Docker RM my container. Okay. Doesn't let you do it because it's running. Can't remove a running container. Okay. Stop it before attempting removal or force remove. So we can either stop it and do the same command, or we can just add a force. And it spits out the name or the ID, whichever you gave it to stop it. Now, if we do BPSA, which is Docker PS minus A, it's no longer, it's not there, it's gone, cannot recover it. And that is one of that's intentional. Docker images and containers are intended to be stateless and restartable with no ill effects. The other way we could have done this, if we wanted to make sure that it was removed when it died or stopped every time without having to go and remove it manually, we could have tacked on a /-rm, which is remove so that, okay, Docker PS, here's our image, okay, Docker PS minus A, it's still there because it's running. But now if we Docker stop and click this out in post, so we know it's done. Yes, not there, but it's also not there in the exited but not removed containers. So if you want the image, that's usually, either case is valid. It depends on your use case, whether you want it to stick around after it's stopped or whether you want it to always be destroyed when it stops. So you can use that either way. Okay. Any questions so far?
This Docker PSA, when I started Docker, sometime you stop the container. Let's say you worked on something yesterday and you stopped it, but you forget about it and you're just doing Docker PS. Now you're trying to pull image and create a container. It will say, no, container already exists. And you do Docker PS and you say, no, it's not there. So always do Docker PS /A so that you can see the stopped container as well. You just restart or remove that before installing. And that has happened with me. So
very much the same, and I believe the same thing with the ports. If I'm not mistaken, even a stopped container, for example, this one is reserving 27017. We can't use anything else in 27017 until that container is removed. So you might also run into the same thing with ports. All right, customize the port. So this is where we get into playing with the ports. So we can use the -E, which will set an environment variable. I mentioned this earlier. This will override that environment variable setting that is configured in the Dockerfile. Like most any other languages or frameworks, the command line would be the lowest level and take the highest precedence of all of the commands and arguments being merged at runtime or build time. So we can do the same thing. Just do both of these. Port 9000. Docker run. Let's actually try it without a name. So I can show you that thing. All right. Docker DS. Okay, just like normal. Okay, two things to look at here. Our container is exposing 9000. We're still going to talk to it on port 8000. But the container is listening on 9000. It doesn't really matter which order you do it in. It all depends on your use case. You may want to be changing the listening port that the container is listening on, or the application is listening on for some reason in your application. You may be testing something new, and you can specify incoming messages to go to a new port and just test that container with those new messages and just talk to that container exclusively. That happens a lot, actually, in production, large-scale production instances. You're trying to debug something, you can relaunch something with a new port and just talk to that one specifically. Or if you're trying to run multiple containers, you can't share a port, so you can run your container to use for us to talk to it to different ports, but it'll still be listening internally on the same port. So you can play games with that and adjust your environment as necessary to make things work for you. The other thing that I mentioned earlier was we didn't specify a name, so it gave it a randomized adjective underscore name, and this is just adjective. There is a list. It's out. I can't remember off the top of my head, but there is a publicly available list of the names and the adjectives. I assume this is Alexander Graham Bell that they're referring to, but there's it may even be in the thousands, I'm not sure, of the names of scientists and other important mathematicians and so on over history that it will randomly choose from and give you these names. And so we can do the same thing we did before. Localhost, we're going to ping 8,000. Oh, not 8,000. 8,000's up, even though we set the container to listen on 9,000. We're forwarding 8,000 over to 9,000 right here. This is a good example. So the minus ports, minus P, 8,000 local, my port internal. And that would only work if we also are telling the port environment variable that the application's listening on to do the same thing. So this is a pretty good example because it's showing both sides of the conversation. So review, we built an image. We did not build it with a custom tag, but this is an example of how you would do that. List images in registry, Docker image ls, run the container. We showed running containers, running logs, removing container, kill container, and just we should probably put this in the docs going forward. We should, PS minus or dash A is always a good one because that shows you all of your existing containers, whether they're running or not. And I will be run, and I'm just going to use the ID. Okay. Done. All right.
So we have these two scenarios. First, let's say your container is running. When it crashes, with what we have done so far, whenever it crashed, there is the all the data and everything will also be gone along with the container. So first scenario, what if we want to persist our data so that if accidentally container crashes, stopped, we still have our data, we don't lose that. Second, for example, you're just testing your Docker, so you are making some local changes, and now if you're testing, you made a change, you build an image from that and you started container. If you want to make another change, again, you will have to build an image and start a new container, right? So it will be like every time you will repeat the same process. However, we have this concept of volumes and bind mounts. So with this, if you make a change, you do not have to do anything. Your running container is automatically going to fetch that change. Okay? So that is why volume exists. Volume exists so that you can persist your data. Whatever data you are writing in your Docker container, it will be saved somewhere else as well. So first, for example, with the volume, you create a Docker volume. You can specify the name, otherwise I guess Docker gives. So you create this volume. This will create a volume at Docker will manage where it will create that directory. So now when you start your container, you mount that volume like this. This is the syntax. So you specify -v that I want to mount the volume, that when the container will be running, whatever will be inside root data, it should also come into my volume, the volume that Docker created. So now, let's say tomorrow something happens, Docker, the container crashes and stops. Still, you can go into this my volume, Docker volume, you can inspect and you can retrieve your data back. So in this way, your data will always be persistent. And you can create these Docker volumes on a remote host or cloud provider, so that even if the server where your container is running, the whole server crashes, still your data will be persistent. Okay. And another concept is bind mount. It's very similar to volume. It has the same syntax. The only thing that we found is, for example, you already have some data in your local VM and you want to put it into it comes handy when, for example, I said you want to test, you have small change and you do not want to build an image again and start a container. You made a small change in your local VM, it's gonna reflect inside the container, and you make another change, it will automatically reflect. And this comes handy when you already have some data that you want to pass there. And I don't think this is a very good scenario for production because the data is saved locally. but it's good for testing purposes. Now we are gonna do this on terminal. So far I followed along with Max. I have the image running, but as at the end, Max removed that container, I also removed that container. So I already have this my node app image created from last section that Max covered. We are gonna start the container from that image. We are gonna expose it to same 8000. And we're gonna start it into the detached mode so that we can have our shell terminal back. The only thing I'm adding here is I'm gonna mount my source directory that I will show you in my terminal. I have in my Visual Studio, I already have it. I will mount it under this path. And then I will show you how the changes are synchronizing in container and local directory. Okay, so let's start the vertical scenario. So I just copy paste the same command. You can see in my present working directory, I already have this source directory. Inside that I have this folder and I want to mount this under this path. So let's start the container. Okay, we have our container one. So we have two ways to verify now. First, we all know this is a Node.js application. We're listening on this. So let's just see what we are seeing here on localhost 8004. We are seeing hello DevOps, right? So one way to verify that if our changes are synchronizing or not is that, as I said, I mounted my local directory inside the container. We will make changes only into our local environment, and we will see if it is reflecting into container or not. So here I have hello DevOps. Let's write, for example, hello Bitovi. And I just saved it. I did nothing inside the container. In my local environment, I made a change, I saved it here. And let's go and refresh this. So you can see the changes are getting synced, right? So this comes handy when you want to test. You did not have to build a new image, start a new container. You made changes, you tested. And the same goes for the volume. So now whatever, it goes both ways. I made changes here. It got saved inside container. And if you make any changes inside container, it will be reflected here as well. So in volumes, whatever changes will be there, as I guess RG is saying, logs, whatever you're saying, saving in container, it will be saved in volume, and you can always have your data saved somewhere safely so you don't lose it.
And that's actually, if I can jump in, that's actually a good use case for what Ariel was asking about, creating a dev environment where you can have your application up and running, right? And you can be making changes locally to your files and they're automatically reflected.
Yeah, right. And the other way to check this is using this Docker exec command. With using Docker exec, you can execute any command inside the running container. So for me, I want to go inside the shell of the container. So I executed this. Let's go inside and see. So first thing, as we all know that in Dockerfile, we set our working directory app, and somebody was asking this question, right? So let's say, what is our present working directory? So you can see it's automatically set to root app. I didn't go inside it, right? So this means when we set this, the container will always be set to this default working directory, and everything else would be done in this directory. So I guess now this made more sense when you're seeing it inside the container. And now let's see if our source is copied or not. So let's see. And you can see our source is already copied here, and inside source is the same file. Okay. And it has the same content, hello Bitovi. And yeah, let's make a change here and see.
So like you have changed a file, index.js file, you have changed it, and then we no need to rebuild the image, rebuild it. Like it's directly changing in the container itself, like whatever you
Yes,
showed in the local.
exactly. So, okay, the command that I executed was this, where we specify this, we mounted our directory inside. This is exactly the purpose of mounting this, that we made changes locally and it automatically reflects inside the container. Now, if I start this container without this small portion, then whatever changes we make locally, it will be only locally. It will not reflect inside the container, okay? But because I already mounted, this means it's syncing, okay? The changes are getting synced. Whatever there will be inside container in the source repo, it will be in my local directory as well. And whatever changes I will make into my local and in this directory, it will automatically get synced inside that. We will not need to create an image and build a container again. Let's
So
go.
if we don't, if it's unmounted, if we're not mounted, so that time we have to build the image and rebuild and restart the container. We
Yes.
have to do that.
Yes.
Okay.
If you want to mount it and you want to test it, there is no way container can find your changes.
Okay, got it. Thank you.
No problem. So that was local. We have already checked that earlier it reflected hello DevOps, then it reflected hello Bitovi. We also checked by going inside the container, and we didn't do a single thing inside container. We only save the changes inside our local environment. So this comes handy when you want to persist your data, you want to store it onto remote servers somewhere else, in the application, stateful application like database. And this comes handy when you want to test something like we just did. And now Max is gonna show you how we can use Docker in production efficiently.
And then to Pactor's question, how much larger is the image after the volume add? That's a really good question. 0. It doesn't, the adding a volume does not impact the image. So the image doesn't contain a volume. The image contains anything that we copied into it during the build process. So that copy source line in the Docker file, that if that is whatever's in that source directory is getting copied into the container. When you add the volume, you're not adding anything to the image. You're not adding anything to the container either, really. You're just, the best analogy is you're plugging in a drive. You're just plugging in an external drive to the container. If the container blows up, you still have your drive. So that's why we use volumes or bind mounts as persistent data storage. If you have a database is one of the primary examples. You can run your database engine in a container, but unless you want to rebuild your database every time, you need to keep the data outside of the container. So you can upgrade the database engine, you can swap it out, you can have high availability replicas, whatever, but the data is outside the container and persistent. And ideally, actually, just today we had a machine go down that we did have volume keeping the data, but the actual machine itself got corrupted. So we lost everything that was in that volume, even though it's external to the container and the volume were on the same machine, and the machine went kaput. So we lost everything. So that if the data that you're keeping persistent is critical, mission critical data, production, client data, anything like that, you want to keep that volume either specifically always offline or just always be backing up that volume to an external source.
All right, production readiness. Well, the ultimate point of all this stuff is to get code in front of customers, right? Ultimately, there's some practices and mechanisms we can use to make that a better operating system so that we have less memory resources needed, less disk, less time, all these things that go into a smoothly operating production environment. So what the Docker talks about here is that this image is almost a gigabyte. And I mean, what is our code? It's like 11 lines of code, you don't need a gigabyte of drive to host 11 lines of code. So this is where we get into the tags and the base image variants that we touched on earlier. So the Node 15 image is 935 megabytes. It's 99% of the image, as he did the math there. All right. So typically, especially like a highly active image like Node will have multiple versions or flavors, variants. So if we talk about the Slim and the Alpine, if we go to Docker.io, I haven't done this recently. I'm sure there's dozens more. I think Node's on 18 or 20 now, so those will all be available. Different versions, different names. A lot of them have to do with the kind of internal code name of the underlying OS's release. You see things like Bullseye, which is also very small. And there's any number of opinions on which ones you should use, but Alpine is very popular. Slim is also very popular. And it really depends. These are not like universally defined names. It depends on the image and the application that you're using. Then if you go to Docker Hub, docker.io, and look up an image, you'll see everything they offer. All the tags are listed. And for anything that's mainstream in any way, we'll have a bunch of information about why you'd use one over the other. But you can see here, the Slim is 159 megs and Alpine's 109 megs. So almost a 10x, 10 times lighter image. 100 megabytes is way easier to manage than 935 megabytes. So what we'll do is we'll update our Docker file. Do that. Okay, here's our Docker file. So all we did was change the Node 15 Alpine, nothing else changed. Okay, and we'll build it. And this time we're going to add a tag. So we have my Node app :Alpine. So that means it's still the same. This is where the repo : tag comes in. Specifically, like our image name is actually in the Docker terminology is a repository. You see that right here, repository. So we'll build it. I'm going to do my shell so it's bigger. Okay. Failed to read. Oh, I'm not in there. That's an example of not being in the right context, right? I wasn't in the training. I don't know why not, but wasn't there, so I had to go there. So it pulled Node 15 Alpine. We already had cached the layer of changing to the workdir, but we had to rebuild this. So it did that, and it was much quicker. And if we do, I won't use my alias. I will use my alias. The Alpine image is 121, or our build of our app on top of the Alpine image, 121 megabytes versus 945. So clearly, and that means zero difference in functionality. So we would obviously choose the smaller image over the heavier one. They both exist, however. So multi-stage builds, this gets a little bit fancy, but this is really good to know about. So we use multi-stage builds a lot in more complex environments and more complex builds so that we can compile our application and build what we need to do, but only ship what's absolutely necessary to run this application. So it'll be smaller, easier to maintain, and potentially protecting any proprietary code or password secrets, anything like that. And it just allows for more flexibility as the applications grow more complex. You can play around with what you're building and what you're shipping and how you're managing that. So the example we have here, we're going to build a dev image and a prod image. So our dev image will have, it's actually very well explained here. We're first going to build our production image. It's going to be light. So we're building it off Alpine. And then we're changing the npm install command to have the only prod argument. So it's only going to install the dependencies that are needed for a production build, whatever that might be. based on your given application. This is very common for NPM. And we're going to do the same exposing. We're going to do this. And we also have our production run command, which if we go back to our package JSON, which is all kind of defined, we have our start and our start prod commands are defined here. And this is an application developer's responsibility to understand how this works and what the differences might be and so on. The doc goes on to explain about the differences between like NodeMon and just Node and some of that stuff. So when those kind of differences exist, you can leverage them using tricks like this. And you can see we added this as decorator to the from argument. We're just naming this layer or this stage. We're saying from node alpine as prod. This is going to be our prod image. Everything else that happens after this is going into our prod image. Now we're going to create our dev image. So from prod, so all of this stuff, let's create a new image called dev. Now we're going to actually go back and install the dev dependencies so that whatever extra stuff we need for development, like tracing or breakpointing, any kind of support that might have, now that's going to be installed in our dev image. And this image will have its run command, and I will be a little clearer, its startup command as npm start. Again, defined in the package JSON. Okay. So I'll copy this in to our Docker file. All right. And we can build both images at once, or we can use the -- target to specify a stage. Default is running all stages, but here we're just going to build our dev and prod. So we're going to run docker build my node app again, but tagged with a prod tag, and then with the target and the context. There it goes, bunch of cached stuff, but now it's got a new layer to build, the prod npm install. Okay, takes a few seconds, done. And so we'll do docker image ls, and here's the 3 images we built. Let me just show. So here's our node apps, prod, alpine, and latest. You can see the difference here. So 945, 121 for alpine, and then the prod's even slightly smaller at 119 because we don't have those extra dev dependencies in there. We'll build the dev image. And again, so we have that prod layer cached. We reused it, don't have to do it again, save that time. But now we have a new layer to build to install the dev. And we'll do this again. We have our dev, prod, alpine, and latest images. And with the dev attached, it's the same size as the main build, which makes sense. And this is small. And this is a tiny, tiny application. But as you get into more complex stuff, it can make a difference. So here we're going to run the prod or the dev image rather with the bind mount. So we're going to be able to get into our code and make any changes we want. So it's running, and it's up on 8,000. So if we go, got hello world. Okay. We start our prod image, and we're actually not going to do that bind mount because we don't plan on changing anything in our production environment. One of the best practices and sort of grounding strategies of Docker is the concept of immutable containers. And the idea is that at least in a production or stable environment, you don't change a container. You don't add new code. You don't install something new. You absolutely can. I do it all the time. But because that container and all of its changes will disappear when the container is stopped, you have to do it all over again if you want to do that again. So it's generally a good idea to make once you get the changes that you want ironed out, to go back to the Dockerfile and make those a permanent part of your image. And that's where you would bump the version on your image and create a new image. So you can absolutely do whatever you want inside a running container within the capabilities of that container, of course. And that's a good way to sort of like, all right, what configuration do I need? How do I get this thing to work? Do I need to open this port or that port, install this tool or that tool so it's working correctly? But those will not be repeated when you launch a new container off of that image, because they don't exist in the image. So any changes that you want to exist permanently have to go back into the image. That's ignoring, of course, any data or whatever you create that's in a volume, because the volume is outside the image container. Okay, and we've got our prod image up and running on 9,000. So we see we've exposed 9,000, but it's still pointing at port 8,000 on the container, on the running container. Okay, so they're both running. Now, if we go and change something in our dev container, just like we did earlier, hello webinar, it should automatically change. So 9,000 is our production, no change. 8,000 is our dev, webinar changed. Okay. So that's another pretty good example of volume working and when you don't have a volume installed, attached. So word of caution, yeah, multi-stage builds. It took me a few readings of this to fully get what he was getting at here. He says, multi-stage builds to customize container behavior can create issues where image works locally but doesn't work in production. You sort of test your production image. It took me a minute to understand what he meant by that. What he means is, if you're only ever working in your dev build, in your dev container, you're like, okay, it works, ship it. So, and your CI pipeline or whatever your process says, all right, we're going to take our production image and ship it. Well, you haven't tested that. You've only tested your dev container. So all he's saying here is to make sure that you are testing your production image as well as your dev image, so you know it works before you ship it. Can we add multiple commands on run? Yes, you can have as many run commands as necessary. If you go look at any mainstream app image like this Node image, you probably have dozens or more run commands and lots of other kind of obscure stuff that they'll do there to make sure that it's usable and robust by the world, by the community at large. There are definitely cases where you want to do stuff like multi-line, or a lot of people do and commands. This is Copilot writing a lot of this for me right here. But yeah, you can do that a lot, and there's advantages to do one versus the other. I believe in most cases, like I mentioned before, every new command creates a layer. So I can't speak very well to the advantages of one versus the other, but this will only create one layer. So if any of these things changes, it'll rerun it. It won't be cached. It'll invalidate the cache if any of these changes. Whereas if you did each of these on their own line, each layer will be evaluated individually. So this would probably have the same end result, but you might find some efficiencies or tweaks work better in one form versus the other. And I frankly that's about all I can say about it. I can't think of a good example of one versus the other. I'm sure there are many, but that, yeah, I mean, look at that Copilot jumping in right there. So that works as well. And it just depends. I'm sure I could find some documentation that says one is better than the other in this example or that, but I can't, off the top of my head, I can't think of it. Right. And then, so now we're getting into some additional tools. So Docker Compose, because all this stuff, it's hard to remember these commands. It's hard to, it's annoying to have to run them from the command line all the time. Like we touched on a couple times on maintaining environments for periods of time or scaling them, making them robust. It's doable on the command line, sure, but that's a lot of toil, a lot of effort, a lot of things that can go wrong. So we use Docker Compose and other tools to make that more simple.
Okay, as Max said, now with whatever we have done, we have to write a big long command. And so here we can see we have to write the ports, any environment variable, volume, and everything. And if we are doing testing multiple times, we have to write this command again and again.
Yeah, and this can get really complicated. This can get really long. Like one of the internal tools we built here has like 20 lines or so of commands that you need to run to get it to work. So this is a very simplified example. It can get real ugly real fast. And this technique that Crump's explaining makes it a lot easier. Sorry for interrupting.
It's okay. Yeah. We have so many flags that you can specify, and specifically as for this multi-staging build, you might have conditions and stuff. So it can be tricky that, where should I target? Where should I specify the target or the tag? So this is one thing. And another thing, let's say your application comprises of multiple containers, and you want to be in sync that, okay, I have these 4 containers and I want to start those 4 containers in sync, all with one command, not creating image separately for each container and starting it. That's where Docker Compose comes. You can start multiple container with one command. And instead of writing this whole command, you will put everything in a YAML file. This is a declarative way. So you create your file once, and then you just provide the environment variables, and you always use the same command. And so in our today's scenario, we'll be making use of these 2 files. One is the Docker Compose. I can explain you the meaning of each line here. Version is the default version of Docker Compose. It's 3.8 always. This means that this file will adhere to Docker Compose 3.8. And then services is another terminology for containers. When we use Docker, we call it containers. And when we use Docker Compose, we call it services. And under services, we can specify the configuration for multiple containers. In this particular file, we specified only 1 container for now, but when we'll go down in a few minutes, I'll show you that we will contain more than 1 container as well. We specify the name of our container just like we were doing in our Docker run command, we were specifying, and then we specify the image just like that here we showed. And then instead of hard coding, we provided the tag as a variable, and we can override this. The value of this could be provided from environment file. By default, Docker Compose will always read this .env file to check the value of any variables, and it will automatically map these values to the environment variable in Docker Compose file. So in our case, this means we will use exactly the same file. So our environment will be dev here. So this means exactly the same command, but you can write it prod, and you can specify 9000 as Max was using for prod. And then you do not have to change anything Docker Compose. Just change your stuff in .env. Automatically Docker Compose is gonna take care of that. And then we specify the ports, just like the Docker command. We specify the volumes and environment. But this is just one-time hassle. You write one time this Docker YAML file, and then every time you test, you just make small changes in environment, and you run the same command always, Docker Compose up. And that I have .env file. And here the value is provided for the environment variables that we have declared here. And the only thing we are gonna do is Docker Compose up. So you should run this command where your Docker compose file reside, and the name should be exactly same. If like we are running this command, we are not specifying any file name, right? So automatically Docker compose looks for this name under the same level where you are running command, and it will do the magic. So now you can see that our application is up, and yeah, you can run this in a detached mode as well. If you want your shell back, just specify -d and it will be, so you can see we have our DevOps running. And let's try to make changes here. So you can see here in logs that I made a change, and that change, because we used volume in our Docker compose file, we mounted this. So automatically change was reflected in container, and that Nodeman looks for all the changes whenever there is a change. This is specific to Node.js application. Then Node may start the server, and it just restarted. And if we refresh it, we can see the changes also reflected here. So this was one scenario that you do not need to run a long command. Let's come out of it by Control-C. Okay, so now you know that instead of writing one long command, you can just write this. Next scenario, the next best use case of Docker Compose is actually creating multiple containers. But before that, there is a small portion that I want to miss. That for example, you want to create an image as well. Here we just created a container. We didn't build any new image. But if you want to build a new image as well, you specify this section. So after specifying the name, you write this build as it is, and you write this context, and under context, you specify the path of your Docker file. For example, if I write this file in my, so here, if you see dot means my Docker file should be on the same level. So I have it in the same directory. So I wrote it down. Otherwise, you can particularly give the path of your Docker file and target whatever tag you want to give, and rest of the stuff as it is. So, okay.
That's your images. You're probably looking for the containers.
Okay, yeah, so this one is the one that got created just now. So I put it in detached mode so that we don't have that shell, and it's again running on that local host. And it's same thing, just we build the image as well this time. So let's just remove this. Okay, now let's come to the next use case, which is I guess the most important one if you want to use Docker Compose. Let's say, I guess somebody asked question as well. If you have in your application, you want 2-3 containers to spin up all at once, then Docker Compose comes really handy. So it's same thing. The only thing, this was our first container, and we are adding another container. That database container we are providing the name of the container. We are specifying the image along with the tag, volume, restate policy. You can specify that when this container stops or crashes, like fail by any reason, should it always restart, or it should restart only when it stops, or only on failure, or it should never restart. So this is the policy. You can read more about this on Docker documentation as well. And then environment variable. So for our MySQL image, these are the mandatory environment variables. You can always go to Docker Hub, and there you can see what are the mandatory variables. I'm not sure if I already have this open, but you can go to Docker Hub and you can see what are the mandatory variables or what are the optional. So these were the mandatory variables, so we had to provide this. And finally, you specify volume outside of your services so that this volume of database could be shared with another container as well. So let's copy this file. So just to show you again, now we have only one container running. This is the my Node app latest. Okay, but now with this, we intend to run another container for dev because we specify it here, and we intend to run database container as well. So let's.
You have to add the SQL environment variables.
Oh yeah. Thanks. It's Max. Yeah. Let's provide the value for our variables in dot environment. And execute the same command. Okay, that's some reason I.
No, we saw this yesterday.
Okay, I'm going to use the latest image for my SQL.
Yeah.
Okay, perfect. So you can see from here that our MySQL is already ready for connection. This means our MySQL container is already running and our application is also running. This means we already having two containers running. We can see it in by using the D flag.
Can I ask a question?
Yeah, sure.
I think this is the case that I asked before about having the database in a container or having it just in another different server and referencing it from your application. I think this is the case, right? In this case, we are basically creating a container that is a MySQL server.
Yes. Yeah.
But what would be the best practice?
Well, if we want to make use of Docker Compose, it's same exactly. You expose your port so that your application it's able to connect to your database, and then you're already sharing your volume so that your application actually can like read this volume which is inside your database. But I guess in more complex scenarios, production, maybe Kubernetes or those practices are good. Max, you have any thoughts? Because to be honest, I haven't used it for any database applications. It's just few examples I followed here and there. But this is one of the best use case. If you have very small application, you don't need many database application stuff. You just have one database stuff. And but if you have like multiple database instances and you want to back up everything, maybe Kubernetes can be a good option. What do you suggest, Max? You have any?
Yeah, no, you're pretty much right on. So are you asking about a specific use case that you have, or are you kind of asking about like best practices? Because I always say, I used to say anything is possible, but I worked with someone a while ago who says everything is possible. So everything is possible, right? If you have, and I would probably say that this specific example might not be perfect for production because it's all it's all encompassed in this single compose file, right? You probably would have your database controlled and configured by itself in production environment, and your applications controlled and configured by something else, and then they're talking to each other in some way. It's really the same thing in this case, because they're going to talk to each other over a socket, over a network connection, and you just have to tell the application where that database is. whatever that might look like, with if it's somewhere external or right next to it in the, in your local environment. Excuse me. This is a fantastic example of what's really useful in a lot of cases is most applications require a database for state, right? I mean, and most real applications require some sort of database. And if you don't have this set up, then if you're working locally, you have to have a database set up. You have to manage that, install it, configure it, support it, maintain it, etc. Or you have some other group or some other person that's managing your databases, and you have to connect to that. And then you have to talk about your dev database and your prod database and who gets access to it and whatnot. In this case, if you're doing local development, you just, or a hypothetical example, you're starting on a team, or there's an existing application in process. Hey, I want to work locally. You pull the repo, run Docker Compose up, and boom, your application's up and running. You have a database up and running. You may even have a population, seeding script that would seed the database with some data to get started with. And that can all be defined specifically in this compose file. And so that makes onboarding to a new team really easy. Just Docker Compose up. Okay, now I can get started writing something. So, and I think that answers part of your question. The best practice might be kind of what I described, right? For local development, you're working on your local database. If as you go to QA or staging, for example, there's probably going to be a shared database somewhere that environment in your configuration would point to. And ideally, your application would not have to change. You would have, just like we have in the index.js file, where it says most things are defined by variables. And based on the environment that you're standing up, those variables would be different. So your connection string to your database for your local development might just be localhost right there, 3306, right? But in your QA environment, your connection string would be set by some other variable for some other server elsewhere on your network. But your application doesn't know the difference. It's still talking to a database. And that's where you want to get, where your configuration is separated from your code. That's a really big part of this. And it's a constant pain point you see everywhere, where an application has some hard-coded string, or even, even sometimes have, well, we need to do another build. We need to do a QA build. And the only difference is that connection string for the database. And that's like an anti-pattern, where you really want to have your application static and just reading configuration from some external source. And it can be hard to get there if the application wasn't built that way from when it started. But I hope I've answered your question. Can I clarify?
But I think there I have another question there. If I guess it depends on the database provider, but if I'm hitting a data file, like the volume, you're sharing a volume for this server, and you might be hitting the same volume from different containers, I guess it will be up to the database server or the application, the server, the RDBMS, to coordinate the writes and reads from to that database, right?
Mm-hmm. Yeah, I don't know off the top of my head if Docker volume by default, without any configuration, has any kind of locking or resource protection. I don't know off the top of my head. It might, but I would probably leave it to the database provider to manage that. One thing to point out, I thought of this earlier, and this is a good time to bring it up. So this volume is also just local. So if you're running this on your local, this volume is on your local machine. If you're running it in some cluster, the volume is local to that cluster. So you couldn't share this environment to another machine. It's probably, there's always a way to do something, but it's not immediately clear how you might share this specific volume to another machine.
But the volume,
right?
you can set up the volume to be in a shared folder, right? Or something like that.
Well, that might be a bind point, right? That's one of the subtle differences where volume is controlled by Docker and it's local to the system. And there's every possibility that I'm wrong and that you can configure that differently. But for our use case, the volume is local to the system. If you have like you say, a share drive is a perfect example. And in most enterprise environments, share drive is going to be backed up, which is even better. You would bind to that share drive, and then all your data is going into there. To clarify that a little bit, like let's look at in the DB definition there that Karam has on screen. The DB service, the volumes block, and then that line, the DB data colon as the local path, and then the var lib MySQL as the container path. Those two are only linked to each other. So anything written to var lib MySQL is going to get written to DB data locally and vice versa. But if something gets written to var lib my app, it's not going to be reflected to DB data. So you have to set up their volume points properly so that all the data that you want to persist is properly copied, right? So if you wanted, you could just do var lib to DB data and you'd get everything under that directory. But more than likely, you'd probably have var lib MySQL as DB data and then another volume set up as app data colon to var lib app. Just hypothetically making those examples up, right? But you do need to make sure that you design your data persistence and your volumes so that you're capturing everything you need to capture where you want it to be captured. If you have some other directory that's not, in this case, var lib MySQL, as soon as that container is removed, it's gone. So let's go into sort of the bonus content. If you've made it this far, thank you for sticking around. And Docker is just the beginning. We talked about, kind of the natural evolution and natural segue is, well, what about load balancing? What about high availability? And that's outside the scope of this talk, but containers are the foundational parts of all of that. The systems can start to breathe as the traffic increases or decreases, or your load increases or anything like that. Computational needs start to expand, and these more advanced orchestration mechanisms can make that completely hands-off. And so one of our clients, does large-scale online e-commerce, and there would be no way for the system to be maintained by hand, all of the different traffic bumps and certain promotions that they have and the traffic spikes. You could do it by hand, but it'd be very inefficient. It'd be very error prone and just not a good use of human beings' time. I just wanted to tack a little bit of additional stuff onto this. So some next steps, orchestration. We've talked about Kubernetes. There's even alternatives to Kubernetes. I'll add to this as well, Rancher, OpenShift, and then you get into, of course, all the different clouds that we are familiar with: AWS, Azure, Google Cloud, and then there's dozens more that are, it's hundreds more really, but there's a dozen more that are probably good to know about. And those operate, even if they're not showing it to you in the UI, they're pretty much all containers under the hood, and they're actually almost all Kubernetes under the hood. I encourage you to go look at Kubernetes, but it was hard for me to understand Kubernetes until I really understood Docker. So play with Docker a little bit, do some more tutorials, do a few more maybe complex things. And at some point it should just click, or at least enough so that you can get up and running. And then you can start asking these questions. Well, what about if I want to be behind a load balancer? And that, it gets more complicated. Docker Swarm is a sort of older technology that was obsoleted by Kubernetes and similar things. But Compose is still really useful for the examples that we talked about, where your development environment is more than just a single container. the majority of applications will have at least a database, some kind of signaling system, several different services that you may need to stand up to test your little part of your application while you're building it, or even just to have multiple environments. And if you can get that going, you can be ahead of the game, where a lot of people are stuck in the VM world. Like right now, I mentioned earlier in this conversation that we lost a machine. We lost our Jenkins machine and everything that was on there. That's a VM, and now I have to go ask for a new VM and things like that. So there's just a lot of benefits to it. But the nice thing is, because I was running Jenkins out of Docker, once I get that new machine and configure it to run Docker, I just run Docker and it should just work. I had a volume on there that I mentioned. We just were talking about volumes. Since I lost the whole VM, I lost the volume. If I had been backing up that volume externally to another machine or another location, I wouldn't have lost it. And then I could just stand up my Jenkins instance and attach that volume, and we'd be back where we left off. We wouldn't have lost any data. So there's a lot of things that become easier once you get over the learning curve of Docker, which can be high depending. So look at Kubernetes when you get a chance. There's a lot there, and their online, the Kubernetes IO documentation is actually really good, and is frequently used as like the go-to learning source for Kubernetes. So it's very good, and they even have examples. And I would recommend trying a tool called Minikube, which lets you stand up a real-life Kubernetes instance on your local machine. It's running out of Docker. You have to have Docker installed. It runs in Docker, and it is a Kubernetes instance, and you can start playing with Kubernetes that way. But get familiar with containers first. If you do that, I also recommend a tool called K9s. Okay, alternatives to Docker. Docker is the de facto standard, but there are a lot of alternatives. As I say here, it's worth mentioning them, but they're usually used as an alternative for various technical reasons or operating system concerns or resource constraints. Docker can be very resource intensive, and some of these tools are much lighter. Kalima, in particular, I've used when I just wanted to just do something quick and start it up and shut it down real quick. It's faster, it's a little bit smaller. And the nice thing is, any of these tools, you can run a Docker container on any of them without any changes. So they're all cross-compatible, for example, but they also have their own little niches. Podman is a good one. Containerd is one of the underpinnings of much of what we're talking about. Kalima, I mentioned, Builda. They all have these silly names, and when I made this list, it was like 24, and I cut it down to these. They're trying to be specifically like container runners. But there's any other, so you can. This is a public repository. You can feel free to check it out, and just kind of start your journey from there. But I would recommend Docker first. It's the de facto standard. It probably has the best interface. It's the least error prone. So start there. Lastly, my little tips and tricks. I'm certainly not I'm no genius. I learned from everyone else that came before me. And one of those main things was using aliases to speed up a lot of stuff. We talked about how annoying all of these commands can be. It can be hard to remember them, the error prone, etc. So I recommend setting aliases for most of this stuff. D is Docker. You saw me use DLS, D images. Most of these are pretty self-explanatory, and you're not saving a whole lot of time, but it becomes muscle memory after a while, and it just helps you work a lot faster. You can also, get into, I only recently actually came up with this one, the shell function. So instead of having to write docker exec -it container name, and then bin bash. I just run shell container name and it does it. So this is a good one just as like a shortcut. And just, as you find yourself getting annoyed at repeating things over and over again, just write aliases and put them in your bash RC or whatever shell you're using. And so you get them every time. I'm happy to talk about more of that and share more aliases with you, but this is not particularly mind-blowing, but it's very, very useful. And then advanced features like Docker commit, inspect, top, etc. So commit's a good one. So we talked a lot about the immutability and the non-persistence of the data of in running containers. But what if you have made changes to that container? You've installed a tool, or you've created some files, or you've just done some work in that container, and you don't want to lose it when that container drops. So you can actually, there's more than one way to do it, but a neat way to do it is Docker commit, and that actually creates a new image from that container that you can then run just like any other image. So this is a neat way just to save state of a container, any data you might have on there, any new files, whatever you've done, commit it as a new image, which you can then launch as any other container. It's just a neat one that I also learned not that long ago, and it's come in handy several times, especially when you're like iterating on a design or on some bug or something. All these other ones you can look up on the documentation itself. Inspect, top will show you the processes running if you want to inspect that, and then exec is what I just showed you with shelling. So typical use is to shell into a running container. You can run any command. You can run any command inside a container that it supports, obviously, using that command. You use the -IT for interactive. It actually stands for interactive, and then T is for TTY is the kind of terminal it sets up, but I just always think of it as interactive IT. That lets you interact with it. You can also just run a command without interactive. It runs the command and it exits, if that might be. We talked about Docker copy, in and out, can come in handy. And then Docker run. This is probably the last thing I mentioned earlier about like application crashing, and you want to figure out why, or you want to get into you want to launch a container, but you don't want to run the actual application that is set up to run from that default Dockerfile command or entry point line. So you can do that by running the image and setting an entry point. Typically, I use bin bash or bin sh. You can add arguments, but you can actually see in here. So I might do Docker run $EP, Docker run image $EP. And that will expand to entry point bin bash. And it's just a short way of doing it, because that will run a new image as an image as a new container, right? So that's the difference between Docker run and then the shell, which is shelling into an already running container. Slight difference. That's that. I've also got just some kind of comments on the Docker training doc. Nothing terribly interesting. They're there if you want to look at them. And it's worth pointing out that all of the code on that site actually works. So there shouldn't be any problems running that code if you have things set up pretty default. And that's it. That's all we've got.
Thank you so much for joining us for today's Learn Docker training. You can browse the entire Academy roster of courses at bitovi.com/academy. That link is in the description below. And if you're interested in requesting Bitovi services for corporate trainings for your team, your company, you can go ahead and use the link in the description below to request more information. We can't wait to hear from you, and we'll see you next time. Thanks for joining. Bye.